Hi guys, welcome back to my channel. For last couple of videos, we actually covered what is function and piecewise function and what is domain and what is the range, right? So hopefully you guys still remember that, and we just quickly do the short revision. So for the function, we actually just two types, many to one and one to one. Okay, so example is y equals x squared and y equals x plus 1, whatever. Yep. So these two types of functions. And today we're just going to cover with math method 1D, and which is on this side, sums and products of functions. So for this one, the function is actually as a machine, and we give the input, then we process it, and then we get the output. So it's like this one. We got x, which is our input, and we got our machine, okay, which is our fx. Then we get our y value, which is our output. So currently we want our function to do more jobs. So we might need to add them together. Basically, there's another function, we call it maybe gx. It's machine A, we make it machine B, and out to y, okay? So now we just want to combine the fx and gx, but just in two ways, okay? First way is f plus g, and the next way is f times g, okay? This is the second way. And again, we just want our x in and our x in, so our y out and another y out, okay? You may ask, if that possible, we do f minus g and f divided by g. Of course we can, but for this video and for our math method, we only cover the addition and product, which means multiplication. Okay, let's look at example over here. So just clarify some writing or notation. This one means f plus g, okay? So f plus g brackets and x following these two, okay? And for here, f times g, we just get rid of the multiplication sign, so don't write here, and it's just like write x at the end, okay? So let's look at example. First one is fx is square root x minus 2, and again gx is square root x minus 4. Sorry, 4 minus x, 4 minus x. So in here, x greater than or equal to 2 and x less than or equal to 4, it gives the implied domain. Okay, otherwise it's a maximum domain. Okay, makes sense? So the first one, they help us to do the calculation. So we're just adding them together. Then we just get the value over here. So for part C, we just multiply them together, which is over here. Hopefully you guys still remember square root A times square root of B. We can write square root A times B. Okay, that's why it's under the same square root. And later we just plug in the number. We got 1 over here. Okay, so let's move on to the next one. And before we do it, I just gave you guys a question. Why the domain here is this one, and over here is also this one? Okay, we can talk about this one later in next session. Sorry, in next slides. Okay, so let's keep going. For next page, this is a technique actually we used. Okay, we call it addition of ordinates or addition of coordinates, or maybe just like the y value. So what I mean is, if for instance, let's look at this example, fx equals x plus 1 and my gx equal to 3 minus 2x. So if I do fx plus gx, and I want to know, let's say make it like hx, and I want to know h1 is the number of the h1. So I plug the 1 in here. I got F1, just like 2. Then plug 1 in here. Then I got 3 minus 2 is also I got 1 over here. So my H1 actually just my F1 plus G1, and which is 3. Okay. So it means my X value stay the same, but my Y value adding together. This is exactly the key idea of addition of ordinates. Okay. So for example, over here, my X value is -1, my Fx is 0, my Gx is 5, so my F plus G will be 0 plus 5, which is equal to 5. Okay, so it's going to be over here. And if we do keep adding the enough dots, so we can get this straight line. Okay, this is called addition. Basically, you're holding the X value the same, but just adding the Y be together. Okay. And another thing I want to emphasize in here is the domain, okay? No matter for addition or multiplication for these two cases, our domain for our combined function is just like the intersection. Hopefully you still remember this one, the intersection. So this one it means union and this one is intersection. So we just take the combines of the domain and with the things they are common have, okay? So for example, if my F domain is 1 to infinity and my G domain is like 2 to 5 or 2 to 5 maybe like this. So my F domain is going to be like here 1 to infinity, and my G domain would be over here, which is only this part 2 and 5. Okay, so if we take the intersection, it's only the domain of G. Why this case? Because we want all the functions are defined. Or in other words, in our previous examples, we want our machine works normally, without any mistakes. So if we want our machine works fine, we have to give them the correct input, which is X values. So which means the domain should be restricted in and satisfied for both functions. Okay, let's keep going. And for this example, it's a bit tricky. In here, you just say, sir, we just don't cover the F minus G, but here's the case. What I'm saying is F minus G, we can treat as F plus minus G, right? So it's still under the addition rule. But in this case, instead of we adding the Y value, now we do the subtracting, okay? For example, our Fx, when x equal 1, my Y value is 1, okay? And for my G, x equal 1, my Y value is -1. Again, we add them together, so we got here, which is 1, 0, okay? So we keep doing the same thing, okay? Follow the same procedure, we can get this final graph. So for our final year exams, okay, this part is not that important. Okay, let me say it again. For our final year exam, this part 1D is not that important, okay, because it's, to be honest, it's pretty straightforward and it just takes you time to finding enough points and use this addition of ordinates to get the graph. Okay, get the graph accurately. But this can happen or occurs for your stack. Okay, it's still worth to practice and to get the feelings of it. Okay, and for our books, I think we get enough practice. And my suggestion is please do this one and this one. Okay, this two is relatively hard and can practice you with the skills. And also again, for question 13, this is the way I emphasized in my previous videos. This is the final year exam style to define our functions. So for example, here, our domain for both functions is R, and the relation is this one, okay? And for next part, our F domain is R, but my G domain is R positive union 0. So it's equivalent to 0 to infinity square brackets, okay? And for my last one, domain is R, and again, it's R positive union 0, okay? So hopefully this video is helpful and to clarify some basic definitions and just give you like preview for the next videos. So for next video, this part is pretty important and we call it composite functions, okay? For this part, I will use one video to introduce the concept and also go through the examples, and I will give another video just purely for practice. And again, I will use the final year exams, okay, to help you guys to manipulate or apply the knowledge we covered inside the composite functions, okay? So hopefully this video can help you with functions and clarify some dots, okay? If you like my videos, please subscribe and also click like button and also leave any comments to see if you want me to make other videos for the math or physics. Okay, thanks for your time, guys. Bye bye.